Hello, everyone. Welcome back. Today is our last day of learning about derivatives. Well, not really, last day in this unit, but derivatives are going to come up all throughout the rest of the course. But we're going to learn one more way to find derivatives today, and that is by using the quotient rule. Just a reminder, we've already done power rule, chain rule, and product rule, so make sure that you know what those are because those will also come up whilst learning the quotient rule as well. Particularly power rule will come up a lot, and chain rule might also come up some as well. So making sure that you have those prerequisite skills down is going to be key for learning the quotient rule and solving it accurately, or using it accurately, I should say. So basically, the quotient rule is when we have one function divided by another function, and we're looking to find the derivative. And of course, the denominator cannot be equal to 0, just like always. It states that if y is equal to f of x over g of x, then y prime, so our derivative, is equal to derivative of the top times the bottom, subtract, and then subtracting the top times the derivative of the bottom. And all of that's over the bottom squared. So let's see if we can do that with this next example here. So in this example, I'm going to say, well, let's let f of x is the function on the top. So f of x is 2x minus 1. G of x equals x plus 2. What is the derivative of f of x? So derivative of the top would be just 2. And derivative of the bottom, x plus 2, is just 1. So based on that, can we use this equation and plug in those values and solve for y prime? Absolutely, and let's do it. So y prime is f prime of x is the first part, right? So that's going to be 2 times g of x, which is x plus 2, minus f of x, which is 2x minus 1, times g of x, which is just 1. And all of that is going to be over g of x squared. So that's going to be x plus 2 squared. And now I'm going to simplify. This is going to be 2x plus 4 minus 2x plus 1. And those cancel. So we're just going to end up with 5 over x plus 2 squared. And that's our final answer. So this is a very similar one to the product rule, right? Where we're going to write out what are our functions, what's f of x, what's g of x, and then what are the derivatives of both of those things. And that's going to make it so much easier for us to solve these derivatives because we're not doing all of these steps at once. We're solving kind of one step at a time and then plugging it into a larger equation. And you can just directly plug it in your head as well if you'd like to. But I find that for a lot of students who struggle with quotient rule at first, writing out this helps, even though writing this out is not something that helps for everyone, and it's certainly not mandatory to find the overall derivative, right? This is something that some people might do in their head, and other people might do it on paper, as I've done here, just to make sure that they're not taking on too many steps at once. So whatever works for you is best. As long as you're getting the right answers and showing enough work, then you're good to go. All right, let's try a second example here. It says find the derivative of 3x squared over 5 minus x to the power of 4. So let's do the same thing again. F of x is equal to 3x squared, and g of x, the bottom, is equal to 5 minus x to the power of 4. All right, and now let's find the derivatives. So let's do that. So the derivative of f of x is going to be 6x. The derivative of g of x is going to be, I was going to write 5, but nope, 5 is a constant. 5 just disappears. It's going to be negative 4x cubed. So now let's put that all down. So y prime, according to our quotient rule, is derivative of f of x, which is 6x, times g of x, which is 5 minus x to the power 4, subtract f of x, which is 3x squared, times the derivative of g of x, which is negative 4x cubed. And now we have to do all of that is over 5 minus x to the 4 squared. So that's going to be equal to 30x minus 6x to the 4 plus 12x to the power of 5 over 5 minus x to the power of 4 squared. And there's actually no more like terms here that we can add up or anything. We could factor a 6 out or an x out or things like that, but that's not really necessary. We can stop right here and say this is our derivative that we found. Awesome. All right, let's move on to example 3, a little bit of an application of the quotient rule. It says determine the equation of the tangent line to the curve f of x is equal to 2x plus 1 over x squared plus 1 at x is equal to 0. So how do we determine the equation of the tangent line? Well, first we have to find the slope of the tangent line if we have any chance of determining the equation of a tangent line. So how do we do that? How do we determine the slope of the tangent line? Well, the derivative tells us the slope of the tangent line, right? So they're saying that when x is equal to 0, what is the equation of the tangent line? And therefore, to do that, what is the slope of the tangent line? So just a reminder that the derivative is the same as the slope of the tangent line, right? So f prime of x is our slope of the tangent line, and we need to find out what this is when x equals 0. So what they're asking for is what is this equal to? But of course, to find out what this is equal to, first we must find f prime at x, and then after we find both, then we can find the equation of the tangent line. So going one step at a time here, let's first find the derivative. Then we're going to plug in x equals 0 for the derivative. Then we're going to find the y value associated with x is equal to 0. Although that we can do pretty easily. We can just say, well, y must be 1 then because, these disappear when x is 0. And then after that, we can find the b value. So this is kind of a 4-step question that does involve using the quotient rule, but also involves other important steps to do something other than just tell us the derivative. With that said, let's start with the derivative. So what is f prime of x? Well, our top equation here in this case is 2x plus 1, right? So what's the derivative of that? It's going to be 2 times the bottom, and then minus, what's the derivative of the bottom? It's going to be 2x times the top, like that. And that's all over x squared plus 1 squared. So that is equal to 2x squared plus 2 minus 4x squared minus 2x over x squared plus 1 squared. And that's equal to negative 2x squared minus 2x plus 2 over x squared plus 1 squared. So what is f prime at 0, right? What if we plug in 0 here? Well, we will just get 0 minus 0 plus 2 on the top, and on the bottom we'll get just 1 squared. So this is going to be 2 over 1, which is just 2. So therefore, the slope of the tangent line is 2. Now, recall that every line goes by this format, y equals mx plus b, where m is the slope and b is the y-intercept. And we have the slope, and we also have a point on the graph, right? We know that 0, 1 is a point on this graph, and we also know that the m value, the slope, is 2, and from there we can find the b value. 1 is equal to 2 times 0 plus b, so therefore b is equal to 1. So therefore, y is equal to 0x plus b, plus 1. And this can actually be simplified to just y equals 1. And so that is the equation of this tangent line in this situation. All right, let's move on to another one. All right, this next one says, At what points on the graph of y equals to 2x plus 8 over root x are the slopes horizontal? Okay, so in order to find the points, we must first find the x values where the slopes are horizontal. Now, when would a slope be if a slope is horizontal, that means the slope is 0, right? If it's horizontal, if line's horizontal, then the slope is 0. So what they're saying is y prime is equal to 0. Now, what else is y prime equal to according to our product rule, or sorry, our quotient rule rather? Well, in this case, f of x is equal to 2x plus 8, and g of x is equal to root x, which is the same as x to the power of a half. So our derivative of f of x is 2, and our derivative of g of x is equal to a half x to the negative a half, like that. All right. So what's y prime? Y prime is equal to 2 times x to the half, right? And then minus the derivative of the bottom, so a half x to the negative a half, times the top. And that's all over x rather. I was going to say x squared, but no, the square root of, the square root of x squared is just going to be x. So now I need to figure out when is this equal to 0, right? Because y prime we said was 0. So 0 is going to be equal to 2x to the a half minus a half x to the negative a half, 2x plus 8 over x. Now the over x, we can actually, it just disappears if we multiply both sides by x, so we can just get rid of that. And so we're left with 2 root x minus, minus a half x like that. And then 2x plus 8 on the top here. Oh, not 28, plus 8 rather. Then I'm going to move this to the other side to get 2x plus 8 over 2 root x equals 2 root x, which if we multiply that up, we're going to end up with 2x plus 8 is equal to 4 times x, which means that 8 is equal to 2x, which means x is equal to 4. So they didn't ask just for the x value, they asked for what is the point. So then I'm going to plug in my x value back into the equation. Like that. And so therefore our point is 4, 8. So 4, 8 is the point at which the slope is horizontal. Very good. All right, I'm going to do one more question about this, and then we will be done for the practicing for this unit. Do make sure you complete the homework questions. Practice on your own too. You know, there's only so much you can get out of watching me. Do the questions. You've got to do them on your own. And that said, actually, you know what? Give this one a try on your own if you're feeling up for it. And then I'll go ahead and take it up when we're ready. Okay. All right, let's go ahead and read this one. It says a motorboat coasts towards a dock with its engine off. Its distance s in meters from the dock, t seconds after the engine is cut, is represented by this equation for the entire 6-second trip. How far is the boat from the dock initially? And find the boat's velocity when it bumps into the dock. Okay. All right, so let's give this a go. The first question asks, how far is the boat from the dock initially? Well, basically t is t seconds, and s is s meters. So what they're asking is, um, at time 0, what is the distance in meters, right? So therefore, for A, it doesn't have anything to do with derivatives at all. We just have to plug in 0. We just have to say when time is 0 initially, what is our position? So that's going to be 60. And that's going to be 60 over 3, which is 20. So therefore, the distance from the dock initially is 20 meters. So therefore, the boat is 20 meters from the dock initially. Okay? All right. Now let's do B. B asks, find the boat's velocity when it bumps into the dock. Okay, so when would the boat bump into the dock? Well, the boat would bump into the dock when it is 0 meters from the dock. So it would bump into the dock when s of t is equal to 0, right? And they would like to know, what is the boat's velocity at this point, or rate of change, or derivative, in other words? So what we must do is we must say, well, the velocity is the same thing as the derivative of our original equation here. So now what we're going to have to do is we're going to have to take the derivative using what we know about our quotient rule. So let's do that next. S prime of t is equal to negative 10, 3 plus t minus 1 times 60 minus 10t, and that's all over 3 plus t squared. And that is equal to, let's see, that would be negative 30 minus 10t minus 60 plus 10t over 3 plus t squared. And going up here, that means s prime of t would be negative 90 over 3 plus t squared, right? So that's going to be that. And therefore, if we would like to find out the answer to the question, we need to first say, well, when is this true? What time is this true for? Well, this is true. If we solve that, we would find out that the time would be 6, right? This is true when time is 6, right? During the entire 6-second trip also is a clue for that, to kind of clue us into that a little bit as well. So s prime of 6 is equal to, let's see, negative 90 over 9 squared, which is negative 90 over 81, which is about 1.11 meters per second, or sorry, negative 1.11 meters a second. So therefore, the velocity of the boat when it bumps into the dock is about 1.11 meters per second. All right, well, very good work today, everyone. That is it for the quotient rule. The next section we'll learn about in Unit 3 is going to have to do with optimization and also with applications of derivatives. So we'll see you for that. Bye, everyone.